Okay, we're going to talk about the binary concept and what that really means. It was originally uh, designed by a gentleman named George Boole, Boole, in 1853, and he came up with the idea that you could express everything in two states. The light is on, the light is off, the door is open, the door is closed. And he signed these concepts to two characters, a 0 and a 1. This became known as the binary concept. As the Industrial Revolution moved forward in the mid or the early 20th century, 1920, somewhere around there, where industry was ramping up pretty good and we started using more and more electrical power, the need to be able to control this power became imminent. And that is where we start getting into automation or industrial controls. Before, the lines are simply started and stopped by big knife switches. And this proved to be very dangerous to the workers and to the process. So when they started developing control devices, big contactors that would throw the switches for them, they came back to George Boole, these zeros and ones, and they decided to use the binary concept in doing the logic controls. This is still the same today as it was back then. So let's look at what it means, the 0 and the 1 in the binary concept. Using George Boole's theory, we can take the binary 0 and it's going to tell us the device is off, it's false, or it's low. And a binary 1 is going to tell us the device is on, true, or high. So let's apply that real quickly to some basic relay logic. So what we have here is a basic ladder logic circuit. I have a normally open contact going to an output and a truth table. So going by what George Boole said, we're going to let the binary 0 represent an off condition and a binary 1 represent an on condition. So let's see how this works real quick, applying the binary principle. If I look at the input A on this truth table right here, it represents this normally open contact. Right now, with this contact in its natural state, we're at binary 0. If I look at the scan coming in, the scan comes down, comes across, and because that contact is open, it can't get through. So at a binary 0 on my input, the scan is not getting through, therefore my output is false or binary 0. Why is that 0? Because my scan cannot get through. So let's see what happens when the output A turns to 1 when I give it an input from the field. So now when this input goes true and I go from binary 0 to binary 1, what happens is this contact closes. As my scan comes down, now I got a path to my output. It energizes my output and my output goes to 1. So when my input goes to 1, in this situation, it turns on my output and it goes to binary 1. And whatever's wired to the output of that turns on. And this is the way a PLC works. It works off the binary concept. When I look at this, what I am looking at is this truth table, because that's exactly what the processor sees. It doesn't see this ladder logic that is above this. All it sees is zeros and ones. So I can easily see that when I have a binary 0 input in this particular logic, my binary output is 0. When I have a binary 1 in this input, then my contact closes and it turns on the output and gives it a binary 1. This is the basis of the binary concept in a very elementary form for process control.